Hello there. Today I will be doing a tutorial on how to implement the Wii Remote into Unity. So as you can see, I have a regular white Wii Remote that I'll be using for this tutorial. So the first thing you're going to want to do, you're going to want to go to this website, which I have linked in the description, and you're going to want to click Code and download zip. And you're also going to want to click this link right here and download the Unity Wiimote 1-1 zip. Now you're going to go to your downloads folder. You're going to extract Unity Wiimote 1-1, and they have the 1 at the end because I have already done all this. And then the other one is Unity Wiimote Master. You are not going to extract this one. We just need a single file from this one. So we're going to open Unity Wiimote 1-1, and then we're going to click Unity-Wiimote, and that will pop up this window. So that way. So you want to click Import, and once this is done, you will be fine to have done everything. So I'm going to go ahead and work on a project that I've already got some stuff with, but I'm just going to tell you how to implement all this stuff as I go along to change my own project. You can do whatever you want, but you're going to go to Unity Wiimote Master, Assets, Scripts, and then Wiimote Demo.C#. And so you're going to copy this, then go to your codes folder, whatever you're going to call it, go to Show to an Explorer, and you're just going to paste the file that you copied. And now that Wiimote Demo is in here, we're going to open up Wiimote Demo, and this is a very important step because otherwise this huge thing will appear on the left. But we need this file to be in some sort of object, or else the motion controls won't work. The buttons will work fine. I'm not sure about the Nunchuck and everything, but we're going to go to the onGUI function right here. We're going to find the end bracket that it has */, and then right above onGUI, we're going to comment this whole thing out. So make a cube, drag it out here where no one will ever see it, and we're going to add the Wii Remote demo script to it. You have to go into Models, and we're going to drag this into itself in every single place. Now we don't have to worry about rect pointer, IRBB, or IR dots. And now that that's done, we have perfect implementation of the Wiimote in our Unity project. So what we need to do now is we're going to go to whatever you want to do. So for this project, I have it so that when the mouse is moving, the character will start looking around. So right now I'm moving the mouse. So I want to be able to do this with motion controls. So what I'm going to do is I'm going to go to the camera object and open its script. I'm going to go to my main character, and whatever's going to be using the Wii Remote stuff the most is where I would put this part. So what you're going to want to do is first you have to use using Wiimote API. And then we can add a Wiimote variable. I'm just going to call it Mote. And so we have to say Wiimote Manager dot find Wiimotes. And this will scan your whole computer and find every Wii Remote that is connected via Bluetooth to the computer, and we'll put it into an array. So we're going to say Mote is equal to Wiimote Manager dot Wiimotes at index 0, And there you go. You now have a successful Wii Remote variable that will always work as long as you have a Wii Remote connected, except in some fringe cases where it just doesn't work for some reason. If that happens, I found what works is disconnecting your Wii Remote from your computer and closing Unity, and then once you reconnect the Wii Remote and reopen Unity, it should work after that point. But now we have one more thing that I want to do before we connect the Wii Remote to the computer, and that is mote.sendPlayerLEDs. And this contains 4 variables, and each of these respond to which of these things. So if we do true, false, 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 then this one will be glowing, and these 3 will stop glowing. So I'm going to go ahead and do that. But if you wanted to, say, have the player 3 be the only one that shows up, you could do false, false, true, false. And whatever you want. You can even have true, true, false, true, and that'd be everything except player 3 is glowing. So now we need to open up Control Panel. If you don't have that already, you do Control Panel. And we need to make sure that we have View by Large icons. Go to Devices and Printers. Then start holding 1 and 2 on the Wii Remote. Click Add a Device. Once it eventually shows up, okay, now that it says input device, we're going to hit cancel. Click add a device, and input device should change to Nintendo something something. Doesn't really matter, but I think that does tell you what kind of Wii Remote model you have. So you're going to click next. Click next, and then this will start connecting. And if you look at Unity before that's even finished, usually something will show up here. But now, if we start it, then something is still not working, so I'm going to go ahead and close Unity, like I told you to do, and disconnect the device. Make sure to disconnect the device after every time you're not using it, because it becomes really hard to disconnect if either this has been turned off or your computer has been turned off between the time, and it becomes really hard to reconnect to the device. Actually, I'm going to go ahead and open the Unity project first so that I can double check that it's going to work. Now that that's open, add device, hold 1 and 2, input device, next. Next. Joystick connected. That's what's supposed to appear. Sometimes it may not, and I have no idea why. But now, if we turn this on, we will see that this goes from blinking lights to solid, and that's how you know it works. If you can't see it, this is what it should look like. And I am sorry if I am not showing it properly. I do not have my camera open the entire time. But now, we have to get into the actually programming of the motion controls. So, what I'm going to do now is there's a specific set of commands that you have to run before the motion controls will work. Mote.send player... Send report mode? Send data report mode, that's the right word. And input data type dot, and we're going to do button report buttons acell extension 16. Now I don't know what extension 16 it means, but if you just did report buttons acell, it would work perfectly, except you would not be able to use the Nunchuck in anything, and where you want to be able to use the Nunchuck, this works exactly the same no matter what you do. Mote.acell, which is the acceleration stuff, dot calibrate acell, and then acell calibration setup, and then what you do next entirely depends on how they're going to be holding the controller. So if you want them to hold it vertically, then you would do expansion up, If you want them to hold it right side up, like most of the Kirby games I play, you do left side up. If you want to hold them like this, you do A button up. All in all, it doesn't really matter because this only detects 2 ranges of motion. This and this. For some reason, it can't detect this, and I am sorry to say it probably never will because this has not been developed in a very long time. But we're going to do A button up because I want them to hold the remote like this. And then what we're going to do as well is buttons. So you have to be able to press buttons, right? And more importantly, most Wii games, when you would play them, is they would have this, the IR bar, and if the motion controls get out of sync, once it's pointed at the IR bar, that would reset the calibration. Now, most gamers probably aren't going to have an IR bar, and if they do have an IR bar, they probably aren't going to go through the whole hassle of setting it up. So instead, what we're going to do is have it manually calibrate every time they press the home button. So I'm going to do if, that's it, if mote.button.home. And that's how you just do buttons. It's that easy. It's just mote.button. Whatever you want. A, B, 1, 2, plus, minus. They do plus, minus, not start and select. D up, D down, D left, D right. I think I got those backwards. So once they press the home button, though, we just want to recalibrate everything. So we're going to copy this into here. Now, in the mouse look thing that we use to actually look around, what we need to do is create an I numerator. I'd call it something like activate mote. Then we need to use the Wiimote API. And we need a Wii Remote variable. I'm going to call everything mote just for simplicity's sake. We're going to do start coroutine, activate mote, and then what we're going to do is yield, return new wait until, and then we're just going to turn a bool into a system func bool by doing parentheses, equals, greater than, and then we're going to do Wiimote master manager dot has Wiimotes, and this will just basically delay everything until it has Wii remotes, so that the following commands will guaranteed to work. So mote equals Wiimote manager dot Wiimotes at position 0. So now this has access to the exact same Wii remote that my interact function has, and will be recalibrated every time I press the home button, so we don't have to worry about any of that. So over here I have just Bracky's basic first-person camera stuff. So I'm gonna be able to set if mote does not equal null, because keep in mind that not everyone's going to want to be able to use a Wii remote for this stuff, so we have to add these conditions every time. Then what we're going to do is we're going to say we're going to make a float array, because the acceleration values is in mote dot acell dot get calibrated acell data. Both of these are float arrays. Float acell equals that. Make sure it's an array, I forgot to do that. So now, this will overwrite this data and basically say if we have it rotated like this, that'll be the Y value. And if it's rotated like this, it'll be the X value. So mouse X, we're going to set mouse X, we're going to set to A cell at position 0. If you see code sporadically appear and disappear, just ignore it. It's failed attempts to make my code better when I should have just been following my preset data. Mouse Y equals negative A cell at position 1. And now this looks fine and dandy, but it's actually just a little bit too big, because this will not be set to 0, this will be set to like 0.3, 0.3 something. So we need to subtract 0.3f from both of these things. Or add it in this case. And then we're also going to need to add a dead zone, because nobody has perfect hands. Like, this may look good to me right now, but I'm actually shaking it a little bit. So we're going to set as well, if mouse X is greater than negative 0.3 F, and mouse X is less than 0.3 F positive, then mouse X is equal to 0. And we can just copy and paste this for Y as well. And so now, this should work, and we should have a perfectly fine movement system, or not movement system, but looking system for this. And usually you will have to press home before you start, so be sure to tell players any buttons that you need to press to resync things, because sometimes it just doesn't work. But as you can see, based on what I'm doing, so if I reset it here, if I look up, it looks up. If I look down, it looks down. Up is up, left is left, right is right, and everything you could ever want is right here. It's really hard to show it when I'm pointing away from the camera, especially when I'm not even doing a good job of doing that. And so now we have that system moving perfectly. So next we need to go to the movement system. And so you know how your movement system will work, I do not. But in my case, I have it working with an input.getAxis. And what I'm going to change it to is just up, down, left, and right. So of course I need to add all the Wiimote stuff using Wiimote API. Wiimote. Start protein. Activate mode. Activate. And this time we're going to make it public. Make sure it's not enumerated and not enumeratable, because those were very easy to mix up. Set it to, and then we're just going to go to mouse looks and copy this. Then in this thing, whenever I'm resyncing it. So there is a problem where occasionally, if you have something connected, like this Joy-Con or Nunchuck, then sometimes this may unplug itself randomly and then replug itself back in. And it's all based on how good your connectors are. I think it's very rare to find a Wii Remote and Nunchuck and everything with good connectors, since the thing is so old and Nintendo stopped making them a while ago. So you're going to want to be able to reset it every time it accidentally disconnects. So we're going to do that during the resyncing function every time you press home. So find object of type. Find the object that you're doing for the movement. For mine, it's called player movement. Dot activate. And make sure that we start the coroutine. Otherwise, it won't call. So now with that we have this, just under my whole movement system, or over my whole movement system, it all relies on these two variables, so we just say if mote does not equal null, because it doesn't just have a bool function that says if it's null or not, so we have to say does not equal null. And we say x equals 0, z equals 0, if mote dot button dot d up, then z equals 1. And do keep in mind this will always be based on the Wii Remote's holding upright. So if you want to hold it like a Kirby game and you want this to be up, make sure to rotate it back and find out that, oh yeah, that's actually D left. So, but I'm just having it held vertically, so. My cat is here to screw things up, but that's okay. Nice. Left. And okay, so now we start this whole thing up. I did save, right? I did save. Okay, now assuming you don't have anything else interfering with your movement system, I had to change some stuff off screen. So now, holding up makes me move forward, back down makes me go back, left, right, works perfectly fine. So now, yeah. And so that's how you can get the Wii Remote working perfectly fine, but what if you want a nunchuck? Because that is significantly better for the motion. Well, what we need to do is in our movement system, we need to create a nunchuck data, or we can call that nunchuck, or we can call it chuck if you want. So down here, every time we resync, that's why we have the public thing, and we can say if mote dot extension current extension equals extension controller dot nunchuck. Then what we do is we say nunchuck equals mote dot nunchuck. And that will add this nunchuck to our nunchuck data. So now, over here, over somewhere, where am I? So now over here, we'll say if mote does not equal null, and nunchuck does equal null, then we'll add a condition for if the nunchuck itself is not null. Which, from what I understand, cannot be the case where the nunchuck is null and the Wii Remote is not null. So, the nunchuck does not equal null. Then, we will do the stick. So we'll say nunchuck dot get stick 01, and this will return a float value with 2 positions. So we'll do float array direction equals, not sure if I have another dir somewhere. So we'll say x equals direction at position 0, and z equals direction at position 1. Now this isn't the end of it, because as we see, get stick 01. Now what this is trying to tell us, and if you look in the code of the Nunchuck itself, is that this is actually from 0 to 1, not -1 to +1. So we need to subtract 0.5 from both of these things, and then now it goes from -0.5 to +0.5, and we want it to go from -1 to +1, so we have to multiply all these by 2 as well. And now that all that is done, and because we are using the A cell calibration of 16 instead of nothing, and once I plug this in and start doing everything, the Nunchuck begins working. And this is very exciting, and really happy the last time this app worked. And we're going to also do this extra thing that I want to do, where I have left shift to sprint. So if we have the shift, what I'm also going to do, say, and this is just because I'm doing a tutorial and not planning to actually use this, nunchuck.z. And so we don't have to do any nunchuck.button or anything, it's just nunchuck.c and nunchuck.z is what does this. And so now I should begin moving faster whenever I'm holding the Z button, because that's how I programmed sprint to work, was whenever you hold the shift button. So now if I'm holding... What? I should not be moving. Oh, right. I forget this nunchuck is really bad sometimes. So it might not be the fault of my programming, it might just be the fault of... Yeah, it's just the fault of my nunchuck. So here's my normal movement, holding Z. So as you can see, I speed up drastically whenever I'm holding the sprint button. So, that is how you get the nunchuck working. Now, classic controller. I imagine people will want to be able to use the classic controller as well. So what you do for that is, of course, plug it in, and the classic controller. You would have to create a classic controller data function up here. Classic controller data, CCD, and then you could also adjust the mouse look function for this as well. I'm not going to do that for now, but you will probably figure it out either yourself. So if mote.current extension is equal to extension controller dot classic, and you'll see there was a classic prod there. Say ccd equals mote dot classic controller. Then we could go up here and do everything here. And we could go up here, Control CVV, set this to CCD, and then the function is just CCD dot get left stick 01, which is of course a function. And then it also has some other buttons that you could use. It's mostly just exactly what you think. So let's say CCD dot left trig D-pad left. Then that's how you get that. Or A, and that'll return true whenever this is being held. There's also the ZL and ZR. CL, ZR, but there's also R trigger range and R trigger switch. So this button right here is the R trigger. And let's say you want it so that if it's half pressed and you're playing a gun game or something, your gun fires at half speed. If you have it all the way down, it fires at full speed, whatever. You could do R trigger range, which goes from 0 to 31. And that would be all the possible values. Or if you just want it to work as the same as ZR, then you would do R trigger switch, and that would just be if it's pressed or not. Now, unfortunately, I cannot prove any of this to you because this is not a classic controller. This is a Classic Controller Pro. And for some reason, the Classic Controller Pro does not have any implementation in this. I imagine because it is exactly the same as an Xbox controller or a PS3 controller, just with a home button. So I imagine they didn't implement it just because, you know, if you're going to connect a Wii remote to your game, why are you going to connect a controller to your Wii remote to then play the game? But they did implement the regular Classic controller because someone might have a use for the pressure-sensitive triggers, right? I think it's triggers. So, yeah, that is all that I can help you with right now as far as the controllers and buttons and everything.